Hi, AP Chemistry students. We're going to do another practice problem on how to determine whether or not a precipitate will form. And again, the key to this is figuring out the initial concentrations and calculating Q and comparing it to the KSP. So this one reads exactly 0.400 liters of 0.50 molar lead ion and 1.60 liters of 2.5 times 10 to the second molar chloride ion are mixed together to form 2 liters of solution. Calculate Q and predict whether lead chloride will precipitate. And they give us a KSP for lead chloride of 1.6 times 10 to the negative 8th, which is very small, which means it's it doesn't dissolve very much. It's pretty much insoluble, but we want to decide whether or not it will precipitate given these conditions. In other words, are we over the saturation point by which we'll get a precipitate? Okay, as usual, I'm going to start by just writing the dissociation because that helps me think about the problem. All right, and then I know that I need to calculate Q. And Q, so I can compare it to this KSP. So Q is just going to be lead ion times chloride ion's concentration squared. However, unlike easier problems where they just give you those things, we have to actually use our good old molarity M1V1 equals M2V2 in order to figure out the final concentrations, because these are the initial concentrations before the mixing. So in order to do that, first let's start with the lead concentration. And we have to use, again, the idea of M1 V1 equals M2 V2. All right, so we're going to solve for M2. So for lead, you start out with 0.5 molar and a volume of 0.400 liters, and you're trying to solve for M2, and the final volume is 2 liters. So if you solve for M2, you should get that the concentration of lead initially is going to be 0.10 molar once it's mixed. Okay, so that's going to go in here. Now we also have to do chlorine or chloride ion. And again, we have to use M1V1 equals M2V2. This time, M1 is 2.5 times 10 to the negative second, and V1 is 1.60. We're going to solve for M2, the concentration after mixing, and again, the final volume is 2. If you solve for that, then you can, for M2, then you find that the final concentration of the chloride ion is 0.020 molar. Okay. Now we just have to go up here and plug in these values. Okay. So that's going to be 0.10. Yep, got that right. And then chloride's going to be 0.020 squared. Okay. If you do that, you will find that your Q is 4 times 10 to the negative 5th. Okay, so there's our Q. Here is our KSP. All right, as you can see, Q is greater than the KSP. All right, that means we have too many products. So we have too many products. That's going to drive the reaction, the equilibrium, towards the reactants. Which means that a precipitate will form. And the only difference with this particular problem is they made you do this step of figuring out the concentrations, the final concentrations, and that makes it a little harder. You don't want to just plug in directly these concentrations because that's before they were diluted, and that's how you solve the problem.